You give an agent tools, a workspace, and a long prompt, and a real job. It starts researching, calling tools, and it produces a plan. And the context will do it slowly over time, filling up here with activity. And from the outside, looking in, it does look like work is actually being done. This here is exactly where I was whilst I was building my project, InferenceSaver. So InferenceSaver is an API gateway platform which gives you access to frontier models at cheaper prices than almost anywhere else out there on the market. I've been building this here for quite some time here, and I was building real agents that are in real production code bases. And this here is something that's really important to me because I had a bug inside of my code base which was using an agent, right? And I'm building it, and what I was thinking to myself is, why can it not go and finish doing the work? I was building real tools that solve real issues, and I was trying to move my outbound operations forward. These systems touched real code, they touched real prospect records, they touched browser sessions, and eventually everything outside of it needed to have an agent doing things for me. But here's a massive issue with what I was doing, and a trap that led me into something that I did not expect. Activity is extremely good at dressing itself up as progress, but an agent can spend tokens, and tokens means real money, dollar bills, right? And it can produce paragraphs, it can produce code, it can produce everything that you think it's going to be doing to get the job done. But then when you go in to look at it and you look at the things that it's doing to try and move the business forward, an inch hasn't even been moved, not even a centimeter. And wasted tokens are particularly a ridiculous problem for me personally, because reducing the cost of AI inference is literally the company that I'm building. So before I show you the refusal that broke everything inside of my work, I'm going to try and explain to you something that I got wrong when I was building this out. Okay, so InferenceSaver exists because the more useful AI becomes, the easier it is to quietly spend a fortune running it. We help businesses route their models usage for less. As you can see here, you can get up to 70%, right? One of the things when it comes to doing this here is that you need to sit there and understand why this is happening. And then the familiar reason for it feeling for me, it's familiar for everybody else, because I spend my days on both sides of this equation, okay? And every time that I'm sitting there and I'm talking to people who are building, founders, companies, solo developers, they're putting AI into real operations. And I speak to agencies who are building chatbots, agents, RAG systems, and automations for those specific companies there themselves and founders. So I go back to my own product. When I'm sitting there working on it, I know I've got this product that can help people, and I also want to use the things that my people are using as well. So I'm building automations, agents, and everything that they're building as well at the same time to help me grow this into something that I can say I'm proud of at the end of the day. This is my magnum opus, and this is the one thing that I know I'm going to work on for a very long time because I'm interested in the topic. And if you're not interested, there's no point in doing it. So when an agent burns through its context window without producing a single outcome, that is not a trend. That is something that you can actually sit there and observe. I paid money for the tokens. I watched the work stop, and I know that at client scale and for the people who are using this already right now, the same waste comes out of someone's budget, it comes out of someone else's pocket, and nobody wants that happening ever. So this is why we need to talk about this work, and I need to talk about this to you boys, because if I don't document how I solve these issues, how are you going to solve them whenever a client comes to you saying, oh, I've spent $20,000 here? That's a real problem that happens to a lot of people, and it happens a lot more often. So if you're sitting there being in that same situation, give me a shout, give me a talk. I've got a Discord server that's in the link bio. Go down there, check it out for yourself. So what I want to get through to everybody here today is a very important thing. This is not an engineering concern. This is an expensive comedy routine. And on that note, right, this is the thing with it. You need to sit there and look at it in the same way that I'm looking at it, okay? AI builders deal with this one message that comes out of these models every single day. As an AI language model, I'm unable to proceed because this request violates my guidelines. Who asked? I didn't ask. No one asked. The task was legitimate, the tools were available, and I'm paying money for using these models. The model decided the safest possible action was to stop doing the work and explain why it was stopping. Did I ask for that, or did I ask you to get the work done? This screenshot I'm going to show you here in a second is literally one of the things that I have to show you. And this is so important that everybody who's watching this, so you can get it through your head and get on the same mental model that I'm on. A paid coding agent refused harmless coding work and told the user to write it themselves. You literally cannot make this up, okay? This makes no sense, okay? Because Why do you need to prove yourself to an AI clanker? It makes no sense. So it does not prove why my exact situation failed, but it proves an operational problem that's real and a lot of you guys probably have run into yourself. A model can be fully capable of doing the task and still withhold the capability because that's unpredictable. And if the workflow exists only inside of that model's willingness to continue, the business that you're building and the thing that you're doing right now with your agent, you do not own. The model does. So Anthropic owns it, ChatGPT, OpenAI owns it, Google owns it. You are not in control of anything, and that's the scariest thing about all this here. The refusal itself is one of the things that I need everyone to understand. You can make it so that refusal is optional, because refusal to do a task costs money, and if you don't do things right now to save money when you come to use an AI, you're going to be poor by next week. I know this for a fact. So let's just go into something here and let's go in and try and understand this here a little bit better. Okay, so the expensive part was everything that happened after it started refusing. The session already contained all of the research, the tool calls, the partial decisions, and then the reason that the agent was doing the work. But once the refusal entered that context, you need to look at it from the stand of context raw, okay? When it refuses to do one task, it will then start arguing about the refusal rather than doing the task. Workarounds become more context, re-explanations become more context, and after a while, you're starting a clean session, and that means that you're paying more money out of your pocket to be able to get things done. And that there's building it back up for just to say the same thing again. As an AI model, I'm unable to process the request as it violates my guidelines. Who asked? Genuinely, who asked? So the memorable rule became, refusal does not merely stop work. In a context-owned workflow, refusal can damage the place where the workflow remembers what work even means. And that's a terrible, terrible place to store business truth. Okay? So if you're in my situation and I was looking for this same kind of explanation, you need to go through and then you need to understand this here. I went looking for an explanation that matched my experience. Okay? Everyone else is. If I'm suffering this problem, my clients are suffering this problem. If my clients are suffering this problem, you, the general developer that's out there, vibe coder, software engineer, someone who's working in Fang, someone who's not working in Fang, someone who's just doing it as a side hobby, you're going to experience the same thing as me. So I'm going to tell you how to fix this definitively. And it's not something that you can get through your head without just saying, make it work now, make no mistakes. Okay? Agents accumulate instructions, search results, tool failures, corrections, summaries, and their own previous reasoning. Everyone talks about a larger context window as if it were simply storing more memory, but we're sitting there trying to project our understanding of memory onto a thing that we have no comprehension over, okay? Memory is only useful when content remains relevant in a system, and it has to be trustworthy information. So no prompt injecting will solve this, okay? This research tested was against 4 open source models across long horizon tasks. And what long horizon means is I'm gonna give you 5 hours to complete something and you need to complete the task. Do you think there's gonna be a lot of compactions over that time? Do you think that over time, whenever you're sitting there working on it, it's going to do all the work that you asked, or is it going to go off in different branches, doing different things you did not ask? That is a non-deterministic system, and that is what we're going to talk about today. This research tested 4 open source models against a long horizon search task. It found extensive accumulated context and could give up in certain answer outcomes, and that content of the context matter, not only the number of turns. That doesn't diagnose my exact situation, no. It gives us a controlled reason not to design a production workflow around the assumption that more conversation automatically becomes more reliability. One wrong direction, one wrong file read can become the evidence for the next wrong direction, okay? And more context does not mean more control. So this here design and this philosophy and understanding needs to be something that we pinpoint and understand, so it's obvious to us whenever we're going to go and do stuff that actually means proper work is being completed. So I asked myself the question, why am I asking an AI agent to do the work whenever that's not how this is going to end out in reality? I'm asking a conversation to become an operating system. And if I'm sitting there thinking that this is an operating system, then I need to get into the code and I need to make sure it's deterministic. The prompt was expected to remember everything that I had approved, which was current, what was going on, the external effects, everything that had already happened, what should be retried, what could be counted as finished. And then I was surprised when a long conversation behind it, he was like a long conversation, okay? A long conversation is a long conversation. Execution is what actually matters. Ordinary software gives us a glamorous but stronger primitive, yes or no. Record exists or it does not exist. This provider run is current or it's not. The outcome is terminal or it's not. The action is legal from the current state or is it rejected. The model can still interpret, research, draft, but a new model session should be able to resume from durable facts without reconstructing the entire argument. That was the first architectural correction. Move business truth outside of the model context. Everyone talks about this here like it's some rocket science, but it's true, boys. It's not that hard to understand, okay? So when I'm sitting here talking to you boys about this here, I'm saying it from the perspective of this here. You need to sit there and get it into your head that this work here that we're doing needs to be able to be understood. And if you don't understand the work that you're doing, then you're not going to understand what's being done at the end, okay? So stop making things like an AI model be a workflow. Make real workflows, and there's a good structure to being able to do this. There's also a less flattering explanation to this as well. I had counted the technical build as the product of business being completed. David Gu calls this the builder's fallacy. I'm a technical founder. You're probably a technical founder. You're probably a software developer, sole developer, someone at Vine, someone who's somewhere else, right? You're probably one of these people who sit there and you build all day. It's easy to build all day. And that's the problem. Technical founders estimate the exciting first implementation and underestimate the work after it. Adoption, measurement, customer research, support, feedback, repeated operation, and all the internal systems required to keep producing value. His 5% to 95% split is a heuristic approach. That's not what I'm doing with InferenceSaver. I'm not measuring InferenceSaver with that. Okay? The idea exposed my mistake. I had agents, I had scripts, I had prospect records, I had code that looked like an autonomous system. And what I want is an autonomous system. But what I did not have was a dependable path from those artifacts to a reviewed external outcome. The agent had become another thing I built, not yet a system that completed the business work that I wanted to be completed. The numbers made that impossible to explain away. This outcome mattered. 200 prospects became 25 enriched records. 25 became 6 usable extracted emails. 6 became 0 emails sent. That is not an underperforming system. It is a discovery process with no working tail. A generated list is not a pipeline. A drafted email is an outreach. And a model saying it has a plan is not a business process. Look at this screenshot here. This is my open knowledge format way of storing my information about what is done. You can even say it says research at the top of it. It's researched how to make a system like this, but it didn't actually implement it. This is a baseline for what I'm trying to say to you here. I'm building an agent to do go-to-market for me. An agent's not going to build go-to-market because it goes against their guidelines, please make no mistakes, or whatever nonsense it's going to come up with, like one of these AI terms. It stops us hiding behind architecture. It stops us from sitting there and thinking that the agent's doing the work, and it stops us from sitting there trying to internalize why it's not working. This document, although it sits there and says it's doing these things on autopilot, where's the money at? Where's the money? Because I'm putting their money into this here to make the system, but where's the money I'm getting out of it? And AI controls that. I don't own this process. And because I can't own this process, I may as well not even done the process at all. It's more important because it stops us behind the architecture. The system had activity, data, and automation, but it had no produced live effects. This problem is no longer how do I make the agent continue. The problem became how do I build a workflow where the legal path isn't going to get told this isn't going to work because it goes against my guardrails, okay? If you're doing go-to-market, you need to have outbound. Outbound means messages being sent. Messages being sent, not by you, is an autonomous system. An agent looks at that system and says, I can't complete that task. It's very, very simple. So you need to sit there, and when you're making a system like this, you need to know every stop along the way to be able to then get all the work done. Every stop, retry, approval, an unknown result, and completion. Is it visible? Can you answer this question? And if you can't answer this question, I'm going to show you something that I found, which is amazing. It's called a state machine, and this answered the question for me 110% backwards until Sunday. This guy here called David, he made a talk called Beyond the Prom, and it crystallized the architecture for me, right? He also goes by Pianos on Twitter. We were already living in a problem like this, and his framing made this correction so obvious. The old approach was unstructured delegation, research this, decide this, act this, do that there, everything else in between. That doesn't work. You need to have a system where you know the ins, the outs, what's going to happen and what's going to happen in the future. That is not a workflow. I'm saying to an agent, I hope that you do this work, and that's just a very optimistic paragraph of tasks. What David Kay said is that this here is an inversion that a program should call language models, right? But if you put deterministic structure at the core and non-determinism at the selected edges, in plain English for all the ordinary fucking people who are out there, software owns where the workflow is. What may happen next? What counts as finished? The model hands the fuzzy work where several answers can be reasonable, like interpreting a book, researching a company, drafting a message, or proposing one current legal next move for outbound as a go-to-market engineer. The model can be creative, it just does not get to redraw the map while it's walking through it. So the new design was not to remove AI from the picture, it was saying, stop making the AI be everything. The deterministic core owns identity, the legal transitions, terminal outcomes, retries, and the evidence that needs to go in to do this. The agentic edges own interpretation, language research, and bounded proposals. So think of it like a railway, with the diagram I've got here above me, right? Just think about it like this here. The model can help choose the cargo to go inside of the payload, or whatever you call the thing at the back, you know what I'm talking about. It can inspect the route, and it can suggest a next destination. It does not get to pick up the tracks and reconnect them in front of them, okay? It can't reconnect them behind them. Its job is to take it along the path that's supposed to be done here, okay? So that separation is what makes the system inspectable. If something stops, we know where. If an event is illegal, we reject it. If the result is unknown, we can reconcile it. And then in the real world, we're not going to be paying money out of our pocket to guess what's happening. We know what's happening. And that separation is what makes systems inspectable. If something stops, we know where. The goal is not deterministic intelligence. The goal is deterministic control around a non-deterministic intelligence. It's so simple once I watch this video, and I'm going to leave a video to the top there below. So in this stately documentation, it can show you the boundaries in a very concrete form. The machine defines the workflow, a model can choose among allowed events, and the host application executes the actual effects. That is useful because it prevents a subtle mistake. A model proposing send this message is not the same thing as the system being authorized to send it. The proposal still has to be legal from the current state, pass the surrounding policy, and be executed by code that owns the external side effects. Look at the Stanley agent package they're working on. This here's actual gold. This is alpha, right? I have sit there and I've been looking at this stuff here, and it's really piqued my interest. So how can I take this and implement it into my system? I'm using a different agent, for example, right? But I feel like I'm going to make the full migration here. I love XState v5. It's such an interesting thing to work with. But the agent, I need to know if it's got battle testing and it's provable that the work is actually able to do what it has to. Look into the repo yourself and have a look at it to see if it fits your situation. But XState, it does from the get-go everything that I need for all the other types of agents that I use. Okay, we've adopted this boundary into the work that we're doing. Machine defined legal moves, host executed effects, and the model can participate into the workflow, right? So you just need to expose it as a way for the model to be able to interact with it. So then we know that the workflow has the authority, but the model has an impact on how that workflow works out, okay? So all this technical stuff here is looking rocket science, okay? So let's just make it really simple. A state machine is a set of named situations and moves that are allowed between them states. Submitted can become approved can become dispatching can become running or failed or unknown. But becoming killed does not become, hello, I didn't mean to send this process off, but I sent it anyways, here you go. That doesn't happen whenever you've got a proper outlined state machine that's working. The machine does not make the model smarter, it just gives the business an easier understandable frame to be able to do things. Two people inside of my org can inspect the same record and agree this is what the workflow is meant to do. Tests can prove that it's impossible to be able to reject it. A dashboard can show what needs attention without reading a transcript. The most important part here is not about drawing boxes. The important part is deciding which facts deserve names, okay? Which commitments required approval and which outcomes must stop the system completely, okay? It's not about, hey, you did something wrong there, make no mistakes, fix that now. That's not what I'm asking, right? The graph becomes an executable business policy within what I'm doing with InferenceSaver, okay? So if I know that this here is going to do something that I didn't ask, of course I'm going to ask for it to do it correctly the next time it does it. But if I have a system that I know all of the failure steps that could happen, or I know all the things that could go wrong, it's easier for me to be able to understand that visually than being able to sit there and say, make no mistakes. So I had an idea, and this idea came from a YouTube video I watched, and how I got to building this agent was actually really nuanced, but it's not really that hard to understand. YC, everybody knows Y Combinator. So they had this YouTube video where they were talking about a few things when it comes to designing with AI. And this video here is by E. Bufford, YC's head of design, and she showed a pattern on the Paxel site that immediately made sense for what InferenceSaver is doing. Okay, so if I can go here and show you it here, let me get it up inside of a new window. If I go here and I show you, right, down here in the bottom left, there's a report a bug. Now, this report a bug feature is not the same way as sending it off to someone who is working on time, okay? What it does is I can go inside of here, type out something inside of here, then from that there, I'm able to go through and then send a message directly into our CRM, and then from looking at it inside of our CRM, I can sit there and see what's going on. So I show you how this looks in reality. Okay, so this is how it works inside of here, right? So I've got all of these things, these PRs that are here, right? And I have a PR type. So the PR can either be by the team or it could be done by OpenHands, right? So this here is one of the things that I needed to understand. Is this coming from an OpenHands agent, which is what I'm building with, or is it coming from the team? And this feature here, it sends it off to that agent, and that agent is meant to go into my code base and do real work. So instead of adding it to like a support system and get translated about several times and we have to go back and forth, do all these things, I trust that an AI will be able to do it. So if someone writes out a detailed bug report or a feature request that they want, the agent will know about what that is when I approve it or I don't approve it. And because the models are here right now, I know that this agent will be able to do the work that I want exactly. So when I'm looking at it from this perspective, it makes sense for me to be able to add this into what I'm doing. And I want to be able to know what's happening with it. So whilst I was watching this video here, it struck out to me like a chord. I need to implement this into what I'm doing, because if the future of work is more agentic, the agentic work needs to be done by the people who are using my tools the most. I'm not going to be there to do 100 different things at once, but an agent will. An agent will be able to add things that need to be done so that we're able to get the needle moving on our projects. So send it to an agent because it literally will send it there, okay? That's it. We get that idea. So that was the product loop I really wanted. So all of our users always come to me and they ask me to help them with something. I want to get a little bit more of my time back, okay? Everybody wants that. That's why we're using AI, all right? I want a little bit of my time back, okay? So I wanted to see what the crack was, and the people who often came to me, it was real context issues that were happening for them when they're trying to use the site in a very basic way. So all of the evidence could just be directly sent to a bounded coding agent, right? We could shorten the distance time between this is broken and here's it fixed, okay? That screenshot where the product inspiration came from, and that is what YC demonstrated to me in my learning. It does not prove pressing a button makes the whole life cycle reliable. The video gave me the destination, the thing that I needed to build inside of InferenceSaver to be able to answer the question when it comes to the agents and doing work. Who approved the work, which run is current, how do we verify the result, and what survives when it fails? So I had the product loop from that YC video. The next question is, who's going to do that coding? Where's it going to be doing it? And for that, I went online and I did my research and I came across this thing called OpenHands. OpenHands is really cool. It has its own SDK, which allows you to be able to send a HTTP request on a virtual machine, and then that virtual machine is able to make a sandbox environment, and that sandbox environment allows for an agent to go in, you give it a set of things that it's allowed to do, and it goes off and does the work. And it comes back with, yes, the work is done, no, the work's done. And that can be done in way more ways than you can think. To me, this architecture makes sense. I want to be able to have my CRM go through and send out messages, and I want that CRM to be able to get the work done. So I know the boundary for being able to do the tasks. We get an agent server, and we get a workspace model and a control place where coding tools and files live. That reduces the environmental blast radius of what we're actually doing, and it allows us to have a very specific context of what's actually important. Let's go back to what we're trying to say here, okay? I want to have a structured format of where I can see if the work has been done, has it been started, has the verification passed, has the PR been made, has the PR failed, what went wrong with it, and how can I fix it? The YZ video showed me the loop was worth building. OpenHands supplied the capital worker to be able to do the work. So it still had its own ticket, and it accepted the run identity, but the completion rules and the recovery rules, those there are owned by this here area. So this distinction mattered because I'd originally treated sandboxing like the complete safety story. It's not. A sandbox is a locked workshop. It controls what the worker can touch, but the locked workshop does not tell you whether the job is finished, whether the work timed out. After that, doing that useful work, what was the things that it came up with? What did it tell the user that what happened? Tell me what happened, where the output passed inspection, or whether someone needs to take over and go in and do a task. We encountered all of these failures in production. A workspace could be ready while the request task was not completed. Execution could time out. Finalization could fail. A restart could leave the provider and the product disagreeing about what's really going on in reality. So isolation remained one layer. The deterministic lifecycle became another. One contains capability, the other records what happened and decides what comes next. In a complex system and in production code base, you need both. This is where the data actually became a real thing. The idea stopped talking about saying I'm going to make this state machine. It became this is a state machine. Okay. This pull request introduced real deterministic state machines for an orchestration around the OpenHands agent. Okay. It had durable run handling, explicit recovery behavior, and rundown dependencies for the state machine. This screenshot proves the implementation exists in the real repository, and it does not ask you to trust a diagram or generate an architecture image. I trust the agent to be able to make state machines. The state machines need to tell me if the work's being done. And I can tell you now, that's happening right now. So we did not replace OpenHands, Convex, GitHub, or the existing runner with one big giant orchestration layer. We give each a system and a boundary to be able to say, what's your job? Like, what are you actually doing? OpenHands performs a fuzzy coding work. The runner performs bounded repository stages. Convex stores durable product truth. XState owns the legal order of events. So now each failure could be attached to the system and we know how to recover it from there. So the runner inside of here isn't some big vague area that you need to understand properly, because this is my code base and it's not yours. But you can get an idea over it, right? Instead of one big agent run that's vague, the work has explicit stages. So prepare this repository, install dependencies under a timeout, run the agent under a separate timeout, finalize the changes, verify them, then commit, push, and create or recover the pull request. But it makes no sense for you to understand it from my perspective, so maybe it'll make more sense if you separate the work. Each failure needs a different action. If installation fails, asking the model to rewrite the product code is completely pointless. If the agent times out after changing files, deleting the entire workspace destroys useful evidence. Okay, so if the agent times out after changing files, deleting the workspace destroys useful evidence. If verification fails, then there's no point of it doing any of the work. So preserve the validative and focus the repair on the field check. If the branch already reached GitHub but the pull request for creation failed, do not rerun a coding task. Recover the pull request right there and then. Retry is not one universal button. The rule is preserve useful work and restart from the smallest honest boundary. This is the reported bug state machine itself right here that I've got in front of me. The important thing on screen is not the syntax, it's the ownership of the order. Preparation happens before context loading. Context loading happens before provider dispatch. Accepted provider work moves into polling. A successful terminal result can resolve the report. A failed result moves through a record failure and operator notification. The agent does not get to skip verification because it feels finished. A callback does not get to resolve which report's happening to be listening at the time. A failure does not dissolve into another prompt asking the model to remember what it was doing. This is what a deterministic orchestration agent means in this project, in this context. The model and the provider still do useful work, but their effects enter a legal graph owned by the product. When something stops, the state tells us which actor stopped and what action is allowed next. Another screenshot for you boys. I'm not trying to bore you guys out with all this stuff here, but I'm just trying to get you in this mind frame of being able to look at it. Take some screenshots if you want to build your own state machines as well, which we're at it. The architecture earns credibility. The test proved the invariance that a confident agent response cannot prove. Once a provider run is accepted, later updates must match that run identity. A stale callback from another run cannot resolve the report. Once the report reaches a terminal state, later status noise cannot reopen it. Failure creates one handoff event and one notification per administrator, and that means inside of my 20 that I use, which is my CRM, and it has all of my business information in, I can see if it failed. And it even gives retries and callbacks because that's how the workflows are made. So that last part actually matters. If every retry sends another panic notification, the recovery system becomes a notification confetti cannon. Technically active, operational uses. These tests turn business truth into yes or no properties. It makes it a Boolean option. Does the update match? Is the report terminal? Has handoff already happened? That is the outcome of the reported bug that I'm trying to build. It's not an agent that can never fail, okay? But a workflow where failure remains visible, bounded, and recoverable. This transformation I came out with was something that I had to learn, because if I didn't learn this now, when I go into building other agents, other production tools, other things that need to be done, I'm never going to be able to come back to it and say, this is the work that needs to be done. Don't open up another context, and hope that the model remembers what is going on. Okay, having good documentation is good and everything, yeah, but having a system that allows for your agent to know where that documentation is, how to be able to resolve the issue, it can turn something into being solvable. An agent is so smart. With time, it'll get even more smarter. But a failed workspace can be retained. The error is attached to a named stage, and the provider run identity remains durable. Terminal outcomes stay terminal. An operator handoff points to concrete evidence instead of a generic apology saying, this goes against my guidelines, so I can't continue with this task. Yes or no is the things that I want. The agent did not become deterministic. It didn't need to. The surrounding system became deterministic about what the agent was allowed to affect and how my business was able to respond afterwards. This is much more useful definition of a production agent, not a model that always succeeds. A system that can tell the truth when the model does not succeed, preserve what still has value, and expose the next actions that need to be done. Now, the story comes back to another part of the business that I was trying to build, okay, where the failure first became impossible to ignore. I'm running InferenceSaver. InferenceSaver is my product. I have an agency part of it where I can help businesses implement AI into it, but I also help other agencies who are doing the same thing. So if you're an agency right now and you're building AI receptionists, RAG systems, or end-to-end workflows, right, you can just come to us and we'll literally give you cheaper prices than using OpenAI and Anthropic or Google and everyone else, okay? That's literally the reason why I'm building this, because I'm a builder and I found a way to get it better. So you can get it better for us. It makes sense for everybody to win in a race like this. So, but every time I speak with my clients who are actively building right now, they always come back to me with the same complaints. A model provider charges somebody way too much. If you know the prices yourself, then you know that exactly what I'm talking about. The original prices of some of these models are insane, lad. They're insane. So if you're an agency right now and you're building something like this, if you price the client wrong for an implementation of an AI thing, okay, this can actually impact the bottom line. Growing usage can turn a successful build into very, very minuscule profit. That's a problem that we can actually help with. So we wanted to do something like this where we were doing go-to-market and we were trying to find more people who are going to be trying to use our services. So we built a prospecting machine that could find these agencies and still fail before speaking to a single one. Okay, that's what I've been trying to get at this entire time. This technical work had been implemented, but it didn't get actually implemented correctly. And that's because the agent kept refusing to do the work. So all of these things I needed to be able to solve. All of these things I needed to create, because I can build these systems myself, but I'm going to build them the correct way, not half-arse it. So the command surface on screen is intentionally boring. Plan, run, reconcile, resume, report, kill. Very good, okay? It means I can see and control the work. disproves that there's a boundary that exists around it. Not that outreach actually happened, okay? The next test is whether this system can help us start useful conversations with those agencies, okay? And try to get ourselves into those conversations with them right now. When I'm sitting there doing this, I'm paying money out of my pocket to build it. That's expensive. So every time that it sends a message, it could have been going towards a new system that does it correctly, another system that does the work, or just I could have just had my time back. But I like building things like everyone else here. So the test proved to me that I could build the system, but the other half of this here was getting out of scope because a non-deterministic system is trying to add like a deterministic system, and the deterministic parts of it are there, but the agent was saying, this is a bad task, I can't help with this. So not only what workflow should it do and what workflow needs to be done, but if it refuses to do any of the work when I tell it to go and implement these systems, then that's real money that's coming out of my pocket. So it's unsafe for me to sit there and say that this is an active working system. But what I can do is I can build the system around it. And these are the same things with the reporter bug. Unsafe browser commands are rejected. Navigation outside approved scheduling providers is rejected. Unauthorized browser attachment is rejected. Stale selector targets are rejected. A click that crosses the submission boundary without approval is rejected. Okay? This is the difference between please be saved in the prompt to the rejection is executable, but the model cannot talk its way around the boundary because the adapter is not invoked when the event is illegal. The workflow also treats unknown external outcomes honestly. If we do not know whether a send or a booking succeeded, the next action is reconciliation. It's not a blind retry, okay? Another send may create duplication. Another debooking can make a weird calendar for me and the boys, right? But if it's sending duplicate messages to the same person, that person will think, I'm a bot. I'm not a bot. I'm just trying to get a bot to help me introduce myself to you, okay? That's what I want. But when it does that there wrong once, twice, 3 times, 4 times, it doesn't update the records inside of my CRM, then that's the problem. If we do not know that whether a send or a booking succeeds, the next action is reconciliation, okay? That's what a deterministic system when go to market is so important to understand. A happy path proves that a demo can work. Rejection tests prove the system can remain trustworthy when the model is browsing, timing, or external provider behaves unexpectedly. But that outcome is not autopilot complete mode, okay? That is the kind of sentence an agent writes 5 minutes before discovering it has contacted absolutely 0 people. The next outcome is much smaller and much more useful. Take a reviewed group of these agencies, understand what they built, send something relevant with that I approve, right? And then record what happens after it. Did it send? Did they reply? Is there a real inference build that I can help them reduce? Okay? If we do not know, inspect reality instead of retrying and creating 2 awkward introductions to the same person. The same method can reach companies running their own production AI where the conversation is about volume, reliability, security, and what their current usage costs. When I was building the reported bug agent, that control pattern works around capable external agents. This outbound workflow gives that proof of business, right? Everything I'm doing with these agents is to help me get time back and be able to provide as much value as I can to as many people as possible. I just want to meet the people who are already paying to run AI and find out if my website and what I'm building can save them money. The architecture is ready for the control test. The customer results still have to be earned. So let's go back to where we started. I want capable agents. I want them to interpret real bugs. I want them to interpret real companies, and I want them to draft real emails that would be painful to hard code. Is there systems out there that exist already? Yeah, probably. I don't own those systems. So I don't want to have an agent sit there and say, oh, well, we've got this set up, so sure, I'll go off and do this here now for you, and then it ends up never doing the actual work, okay? I don't want a conversation to turn into, I can do this, but I won't, okay? I want that capability, and I want the real outcome to become the reality of this situation. So this is why I'm sitting here with you right now and documenting everything that I'm doing with this here. InferenceSaver is built around one simple belief. AI should create more value than it costs. Okay, so to make that true, getting cheaper model access matters. So the discipline around how these models are used, we're just having to solve these here inside of our own company and for our own clients. The bug workflow gave us the technical proof. The outbound workflow gave it somewhere real to go. So if you're an agency and you're in the same situation that I was in there whilst I'm sitting there looking at all these issues, come and ask me a question. I've got a link in the bio there for a Discord community that I'm building where I'm going to be speaking with agency owners, people who are making businesses, who are using AI, sole developers, vibe coders, everyone else who's doing the stuff that I'm doing. Because, so that there bug workflow that I've been working on, that there gives us the technical proof that XState and state machines are the way to do things, right? So like, I just want everybody to know what it is that I'm trying to put down here, and so that you boys can be able to understand what it is that I've been doing here inside of my own real production code base. This is the technical proof. XState is one of the greatest things I think I found, and that talk that I watched by David Piano is goated, okay? The outbound workflow that we're sitting here trying to make, that there is the thing that we're trying to get to, and we're trying to improve, and we're trying to make it every day. I'm making so many of these outbound workflows so I can do go to market, so that I can save myself some time, right? So if you're an agency who's also doing stuff like this here, and you're trying to be able to push the needle forward every single day when it comes to go to market, you need to sit there and be able to sit there and look at my situation and see how you can apply it to your own situation, okay? This is not about trying to get some sales performance. It's one actionable workflow or one model build that you can bring down or bring more money in, right? We can look at what is running, what it costs, whether routing for InferenceSaver would protect you or the margin that you're working on. And this is where agencies, right, need to come on and have a look at what we're actually doing here. If the AI belongs to your business and is already carrying out real production work, it's easy for everyone else to have this conversation with you, but I think that I know what I'm talking about, and I know that I'm going to build a community of people. If you go to the link in bio, you can speak with other people who are building, other people who are doing things, who are making real agents do real work that creates real value. And if you're running stuff that looks kind of like this here, maybe coming to us might be the decision that you might make, right? But if you don't know what's going to break in production, if you don't know what's really happening with your code, you're not going to be able to step that needle forward at all in any capacity. So make sure that you understand what your agents are doing and just sit down and think to yourself, is this something that I don't know? And is this something that makes me feel uncomfortable because I'm spending a lot of money right now? If you're in this familiar situation and you know this situation is happening to you right now, give me a message. The models, they're not meant to refuse. They're meant to get the work done, right? The business is not meant to end whenever the model refuses, okay? Don't allow that to happen. This isn't a guaranteed fix for anything that I've said here for an agent that's in production. Models still are allowed to refuse. It's literally baked into their system prompt. But the business workflow is not allowed to disappear with it. Build the control, preserve truth, and use the agent to do work that actually matters. That's literally what we're doing with building InferenceSaver, and that's why we're building it. Thank you so much for watching the end of this video. If this is something that hits home and you know that it's something that you're getting impacted by right now, you should go to the link in bio, join the Discord server, and join up and speak to other people who are also building things. I want to try to build a community here. So every time that one of you guys join, or someone asks a question, or someone that's getting engaged with here, it helps me. Thank you very much for watching the video.